the session on your data structures today. So today we are going to discuss about one of the application related to stacks. So in the previous session we have discussed something. Okay, let me go ahead and show you this. So in the stack applications, what all we have covered till now is nothing but reversing a list. So we have seen that how with the help of a stack we can reverse a particular list. That we have seen it, and then we have discussed the very important concept which will be using regression. I mean what we call the stack application very fluently is nothing but regression, where we have seen the example related to something called as factorial calculation, and along with that we have also seen something called as tower of Hanoi problem that we have discussed it. Apart from that, we have also discussed about something called as parenthesis checker, where we try to make sure that whenever an expression is given, something like this. So whatever the parenthesis we are exactly giving, right or left parenthesis, whatever it might be of different parenthesis, whatever we are giving, whether they're equally been provided or not. For example, if you see here, there is a curly brace here. This is the opening curly brace, what we can say. This is what we usually call it as left parenthesis. Same way for this particular left parenthesis, do we have a right parenthesis or not? We are going to match it up for a given expression. Same way if you see here, this is what another left parenthesis here. We usually call it a normal bracket. So for this particular bracket, do we have a closing bracket or not? That we have identified. So if a particular opening braces is there, for that if you're having a specific closing brace, and if it is equally proportionally been satisfied, then we can say that it is a valid expression. It is a valid expression. But in case if the expression is something like this, a plus b plus c close, so you can see that in this we don't, it is not, this is not a valid expression, right? It is not a valid expression. Why it is not a valid expression? Here you people can see that there is an opening curly brace here, there is an opening normal bracket, but if you see here in the left right hand side there is a closing curly brace, but we don't have something called as a closing normal bracket, which should be present somewhere in between, either after expression c, I mean the what we call the variable c, or it should be after variable b, or it should be after variable a, whatever it might be. So that expression, the closing normal bracket, is missing in this particular expression. That's why we are saying that it is not a valid expression. So that we have, for that also we are going to use parentheses. That is a, these are the some of the applications we have discussed it. And in the previous session we have actually discussed about something called as converting infix expression into a postfix expression. As I told you that there is a three possibilities, right? We do have three possibilities of performing or writing an expression. That is nothing but we have already discussed, that is infix expression. Then we discussed about postfix expression, and another one, the last but not the least, what we have is prefix expression. And we also discussed that this infix expression is a human readable format. Human readable in the sense nothing but a plus b. So you can understand that you need to perform addition of these two particular variables. So whatever the values that have been assigned to these two particular variables, you have to perform addition operation, isn't it? Yeah, but system, as we told that operating system is not able, or your hardware system is not able to perform or understand this particular infix expression, we are going for something called as postfix expression. So postfix expression is nothing but here the operator will be coming after the operands. It's something like this. Okay, A and B are nothing but the operands here. So the postfix is nothing but the operator will be coming after the operands. And whereas coming to prefix, what did we say, that the operator will be coming before the operand? That is nothing but like this, and this is what we call it as prefix notation and postfix. And these are the two notations the system can usually understand so that it can perform evaluation. So that is what we have discussed in the previous session, and how we can convert from an infix to postfix. So we have discussed about this particular topic, and also we have seen some problems, right? We have also discussed some problems, and we have solved some problems related to infix notation to postfix notation. So today, whatever the topic we are going to discuss here is nothing but evaluation of postfix expression. Means evaluation in the sense nothing but you people will be getting some expression. So here, what he means to say in evaluation of postfix expression is nothing but you will be giving a postfix expression. The input, whatever you want to give, you will be giving a postfix expression. And based on that, you will be getting the output here. So the output will be whatever the operations need to be performed, you will perform it and then you will get the output. For example, if you take a equal to 3 and b is equal to 4. So in the input, as an input to this particular expression, postfix evaluation of postfix expression, here you will be giving the input as a postfix expression. What is a postfix expression here for multiplication here? You can see here AB plus. So you have to give something input as 3, 4 plus. Then what should be the output you should get here is nothing but you should get the output as 7. Okay, 4 plus 3 is how much? 7. So this is what the functionality we are going to see. So we are going to see a program with respect to this evaluation of postfix expression, where we will be giving a postfix expression as an input, and based upon that expression you should be getting the output, and that output is correct or not you need to identify it. Okay, so simple, you can see here that infix expression, so 4 plus 3 is how much? 7. What is the input you are giving for this particular program is nothing but here you are giving 4, 3 plus, and the output what you are getting is 7. So it means both are correct. So you can understand. So this is infix notation. You will be calculating it, and within the program will be calculating this AB plus, and it will give you the result. So that is what we are going to see how exactly this particular program is going to work on this. Okay. So let's go ahead and see how exactly this program works. So this is nothing but a normal introduction part related to your postfix evaluation notation. What exactly you have to do here in this particular thing. So that is what been okay. That is what been explained here in this particular scenario. So these are normal expressions. What is saying here. So the evaluation act as a driving force. So this is normal general discussion related to how these stacks can be used. So using stacks, what you people can do is any expression you can evaluate very easily, because stacks makes it easy to convert an infix notation to postfix, and even you can calculate based upon the program you have written it. Okay, so here you know that whenever you people are performing a postfix expression, the expression will be scanned from left to right. Left to right is nothing but something from start from here, and then suppose this is the expression you are given a b plus. So the system will be scanning first a, then it will be scanning b, and then it will be scanning plus operator. So this is the way how exactly this particular thing works, as I already told you. So the character, so here what is the logic we are using here? This is a whenever a particular character is encountered and that character is an operand, then what I'm going to do here is I'm going to push it onto the stack. So what it means to say that I'm going to use a stack here. Okay, I am going to use a stack. Let us suppose this is a stack, and I want to perform the operation something called as AB plus. That is nothing but infix notation. Infix notation is A plus B. So this is the postfix notation. So suppose the value of A I'm taking it as 3. The value of B here I'm taking it as 4. So what is the output so what is the input I'm giving here? 3, 4 plus. So how this particular program is going to work here is nothing but first you will be giving this particular expression as input. This is the input you have given it. Now what the system will do is it will take one by one the character. Whatever the expression we are having here, it will be using it one by one the character. So what is the first character we have here is 3. So whenever you people are actually encountering a operand, if you see here 3, 4 are nothing but here operands. They have been treated as an operand here. Since we are giving it in a format of a string, if you give this 3, 4 plus, so 3 and 4, so this will be taken as an expression. This will be taken as an entire input as an expression which is of type character. So you're giving 3, 4 plus. So 3 is a expression. So here this is an expression. So here 3 will be taken it as a character. Similarly, 4 will be taken as a character, but plus will be taken as an operator. So whenever I am encountering here an operand, I will push onto the stack. So what is so you have given this expression. What is the first character we have here is 3. So simply I'll be dumping that into this particular 3. But remember this particular stack which I'm taking here, this is of type float, and 3 is a character. So before dumping this particular 3 into this particular stack, I need to convert this particular this particular character into float. So how we can do it? Explicitly we can do it, right? Float, and then with respect to it, whatever the expression which we are taking, I. Expression of I. So what do you mean by expression of I here? So whichever the location that particular value is present. Suppose this is a 0th location. So expression of 0. Expression is nothing but exp is a variable which I have used it for defining an array. I will show you, don't worry. So expression of 0 is what we are going to get the value here, 3. This I am converting into float. And whenever you're representing as a float, you know that after dot, after a decimal, whatever the number is there, you will be having 6 digits. So here this is a simple 3 I'm representing. So 3 dot 6 zeros. Okay, 1 2 3 4 5. There's one more, 6 zeros will be present. So that I'm going to store into this, because this is a, this particular stack is of type something called as float. That is up to you people, whether you want to use float, whether you want to use int. And why I have taken here float is, the reason is, suppose in the expression, if you are given ab slash, what is that? Nothing but a by b, isn't it? Suppose I have given the value of a as 5 and the value of b as 3. So 3 by 5 means definitely you're going to get a floating number. And in case if you're taking this tag as integer, because whatever the output you're getting here, that also you're going to push it into the stack. And if you take this tag as integer, then whatever the value you're going to get, so 3 dot 6 bar something, so this will be eliminated, only one will be stored here. So you're not going to get the actual output what exactly you require, or the actual correct result what should be there. So that's the reason I'm actually using here float. Okay, because if you are using division in your expression, then definitely you have to use this as in a format, or the stack as a format of a float. So this is the way I'm going to do. And after that, I'll be using iteration. I'll moving to the next character. What is the next character here? 4. So that 4 also I'll convert into float from character, and then I'll be storing it here. And now whenever an operator is encountered here, what I'm going to do is I will pop out the top two values. I will be popping out the top two values from the stack, and then that operator will be applied on that. So what is the next character you're going to get here is plus. You know that plus is an operator. So what I will do is, whatever the values that are present in the stack, the top two values I'm going to eliminate. I mean pop out. What is the first value you have? So this is your second value, right? So this I'm going to pop out. So 1, 2, 3, 4, pop out. And then what is the next value I have to pop out here is 3. So 3 dot I just pop. And whatever the operator is there, that operator I'm going to apply on these two particular values. What is the operator I have? Plus. So 7 dot. So this is, so finally the what is the output you people? So this output whatever you're getting 7. Now you know that I have already popped out this particular 4 and 3. So means this has become empty. The stack is right now empty. And whatever the result I got here, this 7, I will be pushing it onto this particular thing. And then finally, I will print the value that is present in this particular stack. I will pop it out this particular value from the stack, and then I will be printing that as the output. So finally, what is the output you people are going to get here? This is the program. Very simple it is. Only thing is you will be giving an expression. So one by one, you'll be scanning that the four characters. And if it is an operand, you'll be pushing onto the stack. And whenever you encounter an operator, the first two values of this particular stack, you will be popping it up and perform that operator on that particular values. So finally, you are going to get some result. This result, you will be dumping it again into this particular stack. And later on you will be popping it when no elements are there, then you will be popping it out, and finally you will be presenting that particular result. So this is the way how your exactly your program is going to execute. Okay, I will show you the program, don't worry. So let me go ahead and I'll show you the expression also. Now this is an algorithm that he has presented here. Simply this person is actually using something called add a slash, means whatever the expression is given, he is asking you to use a closing brace. Okay, at the closing parenthesis or the right parenthesis at the left of the postfix expression, whatever is given. Now he is asking you to scan every character of the postfix expression one by one and repeat step 3 and 4 until this particular thing is encountered. So he is using this particular right parenthesis to indicate that that is the end of that particular expression, whatever is given. For that he is using it. So that depends based upon the logic you want. You people can write it based upon your requirement. So here he is using this particular logic. So that's the reason I'm explaining this. Okay. Now, so what is saying, scan one each character one by one and perform the operation. So whenever a particular operand is encountered, what do you mean by operand here? Nothing but the variables like A, B, C. These are the operand, or something like 3, 4, 5. So these are the operands. So what about plus, minus, slash, module, uh, cap? So all these comes under operator. So whenever you people are encountering something called as operand, simply push it onto the stack. What is asking you to do is simply push it onto the stack. Now, but whenever you people are encountering an operator, so he didn't write anything, some operators, O is nothing but this is a representation of operator. So what are the operators just now have represented? Plus, minus, division, module, cap. power. So these are, apart from this, we have other operators also. For timing, we are using only this one in our discussion. So if any of the operators encountered here, what is asking you to do is simply pop that top two elements from the stack. So whatever the elements are present in the stack, top two elements need to be popped out, A and B. And then what is asking you to perform is evaluate B O A. What do you mean by O here? Operator. So whatever the operator is encountered, you'll write it. Something like we have written a B plus. So first A you'll be storing into the stack, then B you're going to store into the stack. And whenever you're encountering plus, you will pop these two A and B from the stack and simply perform A plus B. That is what he means to say. So where A is the topmost element from the and B is the element. So here two elements now. So A will be representing the topmost element. Means this is your second element and this is your first element. Okay. And how it is second is nothing but simple. See in the stack, what is the first element here? A. You're pushing that A, and then B, you're pushing it here, isn't it? So what you're doing? So here A is the one which you, so if you see here, when you're popping it up, what is the first element you're going to come out here? B. So this is your second element. And then you will be popping A here. So A is nothing but this is your first element which has been popped out. And then you'll be performing A plus B. That is what he means to say. And after performing this particular operation on that particular operands, whatever the operands we have and whatever the operator we are having, then push the result of evaluation onto stack. So once you are doing A plus B, that is 3 plus 4, you're getting the output as 7. That 7 again you have to push it into this because you have already eliminated this B. You have popped out B and H. So here again you will be pushing out the value something whatever the value you have here is 7. Set result equal to the topmost element of the stack. So this is will be representing the topmost element here, and finally you can exit from this particular location. Okay, so this is the way how exactly your program is going to work. So let me show you. This is an infix expression I'm having. So before writing that, I just wanted to focus on this. So this is the expression I have: 9 minus this 3 star 4 bracket close plus 8 then bracket close by 4. Let me first convert into a postfix expression. I want to convert this infix expression into a postfix. Why? Because you know that what is the input I'm going to give for this particular program is a postfix expression. So let me convert into a postfix expression. So what we have to do, remove first brackets. So you can see these are the brackets we have, this one, and within that you're having inner brackets. So first the inner brackets I'm going to eliminate. 9 minus bracket open. So this is a operand, this is an operand, this is an operator. Postfix notation, how we can write here? 3 4 star, isn't it? Plus 8 slash 4. Now what I have to do here in this case, now I have to eliminate these outer brackets. So that, what does that mean here? If I want to remove this particular outer brackets, oh sorry, there is a mistake here. There is a small mistake. This closing brace is after something called as 8. We are having this, okay? So this we have removed it. Now you can see that this has become one operand and this is your second operand. So in between two operand, I am having an operator something called as plus. Okay, let me write it one more time so that if you don't get confused here. So what I'm going to do first, I am going to remove the inner brackets. So when I'm removing the inner brackets, what is the expression I'm going to get? 3 4 star. Cool. So that is done. Now what is the bracket? So this bracket is gone, this is gone. So after 8 I'm having a bracket and before 3. So here I'm having a bracket and then plus 8 and then I'm having a bracket slash 4 9 minus. Now you can see that this is one operand here. Let us suppose A, and this is another operand B. Now I have to remove these brackets. And so what is the expression here? A plus B. What is the postfix notation here? AB plus. So 9 minus. What is the expression here? AB plus. So A is 3 4 star. B is 8. Then plus. Now this has become one expression slash 4. I hope you people are getting. So this is your expression A, this is your operand B, this is your operand C. Now what I have to do here, there is minus and there is plus. I mean, sorry, this is a slash. This entire thing is one operand now. So if you see here, there are two operators. We have minus and slash, which is having highest priority here. First, you can see Slash is the one which has the highest priority, isn't it? Slash is the one which has the highest priority. So first I have to remove that. So 9 minus, compared to minus, slash is the one which has highest priority. So first I'll be doing b slash 4. So b slash 4, I mean b slash e means how can I write bc slash. So what is b here? 3 4 star 8 plus is b. Then what is c here? 4. And then finally I'm writing it as slash. Now this has become one operand, let us suppose b, and this has become operand a. So whenever you're having something called a minus b, what is the postfix notation here? AB minus. So a is nothing but this. What is b here? 3 4 star 8 plus 4 slash. And then what is the operator I'm having here? Minus. So that minus I'm writing it here. Okay, this is your operand a, this is your operand b, and this is your operator, whatever the operator you're using. So finally, what is the expression I got here is 934 star 8 plus 4 slash minus. Now this is what you people have to give it as the input to this particular program. Then automatically it is going to perform the operation. So automatically it is going to perform the operation. Okay, let me erase it and let me show you the expression. Please do remember this 934 star 8 plus 4 slash minus. So let's see the expression. What is the expression you're going to get here? So what is the postfix expression I got here? 934 star 8 plus 4 slash minus. I think this is the expression which we have got, okay, after solving. So this expression is what I'm going to give the input. So how your algorithm is going to work? This is the one. So you'll be scanning the character one by one. So first your scanning character is 9. You're going to push it onto the stack. Then you got 3, push it onto the stack. Then you got 4, push it onto the stack. Then you got star. You know that star is an operator. Then what I have to do? First, I need to pop the first two elements, whatever is present in the stack. What are the two elements I have in the top of the stack? 3 and 4. I'm just popping it up. Okay. So this is your second element. This is your first element. So 3. So what is the operator I have to apply here? Multiplication. So 3 star 4. What is the output you people got here? 4. So when you got this output 12 here, this you have to dump it into the stack. You have to push it onto the stack. So you can see here 3 and 4 have been eliminated from the stack, but the value 12. Okay, sorry for the inconvenience. So here the what is the output you got? 12. So 3 and 4 have been eliminated from the stack, popped out from the stack. And the new value what we got after multiplication is 12. And that I am going to push it onto the stack 9, 12. And after that, what is the next element I have here? 8. So 8 is coming. So 8 is an operand. Push onto the stack. You got it here. And then what we are having here? Plus. So you know that plus is a operator. So what I have to do? Pop out the first two elements from the stack. What are the first two elements we have in the stack here? 12 and 8. So this I'm going to pop it up and I will apply this particular operation. I'm going to apply this particular operation. What is the operation here? Plus. So 12 plus 8 is how much? 20. Now this result I am going to push it onto the stack. So you can see here 20 is pushed onto this particular stack. After that, so plus is completed. Now next is 4. So 4 is an operand. I'm simply going to place the 4 here in this particular location. And after that, I have something called a slash. What do you mean by slash in this particular scene? This particular, so slash is a operator, right? This is a operator. So what shall I do now? So simply first two elements I have to pop out. What are the two elements I have here? 20 and 40. Remember here, this is important. This is your second element and this is your first element. So what is output? 20 by 4 I have to do. What is the output? I'm going to get 5. Then that 5 I am going to push onto the stack 9 and 5. And finally the last operator what we have scanned here is minus. So minus I'm scanning it. So simply whenever you're getting an operator, what is the condition we have to do? Remove the first two elements that are present. So we are left only with 2 here. 9. So this is your second element. This is your first element. So 9 minus 4 is how much you're getting here. And that I am pushing it onto the stack. And finally, nothing is left here to scan here. So whatever the value is present in the stack is the result. So I'm going to pop it out. So finally, the output, what I'm going to get here is something called as 4. So this is the way how exactly your program is going to work. Okay. So I hope you people have understood this. So based on this, I will show you the example. I mean, show you the program. Okay. So just a minute. Let me show you the program here. Yeah. So this is a program related to your expression, how to write it. Okay, I'll just explain one by one. You just concentrate here. The first thing what I have included here is two header files, something called as stdio.h. I think you basically know why we are using this stdio.h. Nothing for standard input output operations. So printf and scanf will be working using this particular header file stdio.h. And after that, I have used another header file here, something called a C type H. So what is the C type here is nothing but this is character type. So since I'm going to store the expression, I'm going to store the expression 934 star 8 plus slash minus whatever it is. So this is an expression. And we know that expression is always represented in a format of a character or strings. So whatever the properties that are required with respect to this character and string, I'm going to get it from this particular header file, that is C type. This is a character type dot h. What that is what exactly meant by this particular string. Okay. So first I'll be declaring here. So I'm declaring a variable max, which is a size 100. What is a size? Because this is required because I'm using a stag here. So in case anyhow, it will not be overflowing it, but there is a possibility it may overflow sometimes. You may be giving less amount of space. So that case, I need to find out if top is equal to max minus one. So what is the value of max here? 100 means 0 to 99 is we are going to use for stag. So in case if you have used all the 99 slots here, so definitely there is no space to add or push a new element into this particular stack. So what I have to simply display here is overflow. For that reason, I'm using this particular variable called as max. I'm defining this particular variable. And anyhow, I have given a lot of space here. That much is not required. Even you people can give it 50 also by default. Now, since I'm using a stag here, right? I said that this is a stag. So stag is nothing but I'm going to you represent stags using arrays here. So here you can see that float st stag. So this is a stag which is of type float. So all the floating values will be stored here in this particular thing. So one by one, whatever the expression we are having, that is 934. So 9 is a what is this? This is a character. Now this character I'm going to convert into a float. How? I will show you in the program. And after converting into a float, I'm going to store it into this particular stack. That is what we are going to do it. For that, we are using this tag of max and it is of type float. Then int top equal to -1, that you people know why we are representing -1. Initially, there are no elements present in the stack. So obviously top will be representing -1. So void push. Now this is an operation which will, this is a method which we are using to push a particular element onto this particular stack. So definitely I need a stack here and whatever the value I want to push that. So here the value is float. It is of type floating point. Then we have something called as pop. Pop in the sense we wanted to pop the element from this particular stack. So finally, this is an expression where we will be converting or evaluating a postfix expression. Okay, means this is the one where we'll be performing the operation and we will try to get the desired output, whatever we require here in this particular scenario. Okay, so let's enter into the main function here. Let me go a bit ahead. So I hope you people have understood the starting, but now let's see the main function. If you see a main function here, so I have declared a variable called as float value, because this is a value which will, this will consist of the final value, whatever the value I got, what is the output I got, the result for the previous expression here is 4, and that 4 will be present here. So what is the output I'm going to get here is 4 dot 0000. Okay, 6 zeros. So first thing is printf enter any postfix expression. So I'm asking to enter a particular postfix expression. What is a postfix expression which I asked you? So 938 star plus 4 slash minus whatever you got it. So that I'm going to express here in this particular. So you have to give it. So since I told you that expression, right? So expression will be always in a format of a character. So that character you're going to place it using this particular function. So we are using a function called as getters. Okay, so you people can use, but that's up to you how you wanted to use. You can use a scanf function, or you people can use a getter function. That's up to you people. So I'm leaving on to you how you wanted to use. In this, I have used it directly the getters function. So I will be reading the entire expression directly. Now let's see here, value equal to evaluate. So this is the function I'm calling, and in this I'm giving you the expression here. So from here the control will be transmitting to this particular location here, float evaluate postfix expression. And now here the performance. Once the performance is done, what is the output you people are going to get here is something like 4, and that 4 will be placed here in this particular location. So value of the postfix expression is this. And if you see here, this is what I wanted you people to concentrate here. What did I give? Percentage. Usually what is the expression of giving it? Either percentage D, since it is represented in a format of float, we give it as percentage F. But in C language, when you people might have discussed it, you know that percentage dot to F in the sense nothing but after decimal, suppose 4 dot, I wanted to print only up to 2 digits after decimal number. Okay, after point dot operator, I want to print only 20 or whatever the value I'm getting up to 2 digits. I wanted to print it. Suppose you're getting the output as 3.8972. I want to print only up to 2 digits. So that will be something like 3.89. Okay, anyhow, there will be a round figure. You take it 42. So you'll be getting an output something like as 3.89. So this is what I'm doing. For that, I'm using this percentage dot 2f. If you want 3 digits here, you can write it as 3f. If you want 4 digits, you people can write it as 4. That's up to you people. And finally return 0. So this is the main method what we have. So let's go ahead now see the evaluation. The evaluation is very easy. It's very easy. First thing what you people are going to do is you'll be simply calling that function float evaluate postfix expression. Why I'm using float here? Because this is a method which will be returning you the value. What is the value I'm going to get here? So 4.00. This is the value I'm going to get it, and that is what I'm going to present here in this particular case. So if we see here int I equal to 0, float option 1 option 2 value. So I'm taking here, these are the variables which I have declared here. Option 1 option 2 is nothing but I'm going to pop out 2 elements here, so that 2 elements I'm going to store into this particular variables, and finally whatever the value I'm going to get it. So while expression of I is not equal to /0, so initially what is the value of I here? 0. So that expression, what, okay, sorry. So whatever the expression you people are going to take, expression, I said that character expression is an array. So within this array, you people are storing the information. What is that? 934 star slash uh, 5 minus something, some expression which is something like postfix. Okay, whatever we have seen it in the what we call previous one. So here this is 0 1 2 3 4 5 6, and this is the expression. This is what I'm calling it as exp. Now what he's exactly doing here is that first expression of I, so initially what is the value of I is 0, so he's taking this one. While expression of y is not equal to /0, obviously after this you will be having /0. So it is not equal to /0, enter into it. If each digit of expression, each digit is a function which determines whether it is a digit or not. Okay, each digit is actually a function which determines whether a particular value, whatever you have read from this particular location, is a expression. I mean, this particular expression is a digit or not. You know that 9 is a digit, isn't it? It is a digit. Okay, it is not an operator. It may be a character, but it is a kind of a digit. So what it is going to do, it is a digit now. What did I tell you? When it is a digit, I need to push that into this particular stack. So that is what I'm doing, push st comma. So before inserting this 9 into this particular stack, this tag is of type, what did I tell you? It is of type floating. So I need to get a value something like this. So what does that mean? Whatever the value that is present in this particular expression, I need to first convert into something called as float. So this is the expression for that. So this is the expression push st comma. St is nothing but the stack. So this is the name. So here I'm using st. So this is your st. And within this, I'm storing the information. You can see here float. Float expression of I minus 0. So this is a character one. Why I'm doing it? So it's simplicity for I'm using this particular expression. Whatever the expression I'm having here, what is the value? 9. So 9 minus 0. And that I'm converting into a float, and then I'm storing it into this particular expression 9.000, because 9 minus 0 obviously will be getting 0, and that you're going to store it. Why it is required 0 here is nothing but for, because if you're not doing that, because it's a character, right? If you're not able to do this, then definitely the output whatever you're going to get will not be in a specific manner. That's the reason we are doing this particular expression here. Okay, and then else part. So same way we are going to do. Okay, I will explain with this. So first you got 9 now, so that 9 will be stored here. Next to 3. So else part will not be executed. So I will be incremented. So if you see here, I will be incremented after else. You can see here this I plus plus. Then again it will come to the top. So what is the value we have here? I this time. So I is equal to 1. So what is the value we have here? 3. 3 is a digit. Is digit expression of 3. It is a digit. It is not an operator. So simply what I have to do, I have to push it. Now this time st. Next. So initially top is present here. Now top has been incremented here. So that is what push. Push means you have written a function for this particular push operator here. You can see here. So you can see here, there is a push function here, pushing float stack, float value. What is the value I have here? 3. This I want to store. So first I have to check if top is equal to max minus 1 or not. If this condition is true, that means there are no space to insert an element. So simply I'll say stack overflow. Else what I will do, simply increment top. Now you know that already top is present here. I already have a space. So what I have to do, top plus plus. Now top is pointing to this particular location. So st of top equal to value. So st of top means this location equal to value. What is the value I have here? 3. So this after converting it, I am storing it into push and value. So after converting into a floating point, I am inserting here. Then 4. Again after this, what will happen? Again you'll be going back. After push is completed, after this particular push is completed, you'll be again coming back to your first position. What is the first position? This one. I will be incremented. So when I is incremented, again we'll check the condition. Expression of, so this time the value of I is 2. So expression of 2 is not equal to slash 0. Obviously it consists of something called as 4. So when you are checking, is it a digit or operator? It is a digit. Push. Simply you're going to push over, you first convert into a floating point and then push it onto the stack. So 4.0. This is the way you're going. So top is right now here. And then what we have to do finally, you can see here there is an operator. This I will explain it. See, so now this time when it is coming, so I value becomes 3 here. It will be checking the condition. Now if you see here, it will check here whether it is a digit, but you know that this is not a digit. This is the operator. So it will simply, the if condition gets failed and you'll be jumping to the else part. Now what I have to do, whenever you people are encountering operator, pop out the first 2 elements. Pop out the first 2 elements that are present on top of the stack. What are the elements that are present in the top of the stack here? And as I told you, that 4 is your second element, 3 is your first element. You can see here. That's the reason I'm using option 2. Okay, so this is the second element which I'm popping it up first. So option 2 will consist of 4.000. And what about option 1? It will consist of next element. What is that? 3. So option 1 is 3. And then switch, I'm going to use a switch expression depending upon the operator whichever has come up. Now what is the operator that has come up here? Star. So multiplication. So based upon that, what I'm going to do is I'll perform the multiplication. So there are 5 cases I have written here. So option, so here you people can see now. So option 1 consists of, sorry. So here option 1 consists of something called as 6 zeros. Option 2 consists of 4 6 zeros. Okay. Now what I'm going to do, so what is the operator I got here is multiplication. Where is multiplication here? Here. So value equal to option 1 star option 2. It will perform. So 4 into 3, how much you're going to get? 12.6 zeros. This is the option you got. So where I'm going to store that in a value, you can see here value equal to option 1 star option 2. So what is that? Whatever the output you're getting 12 here, that I'm storing into this. And since I have popped out, remember this, if you have popped out this first 2 elements means these slots have become empty. Now top is where exactly top is pointing to now? Top is exactly pointing to this particular location because that is empty. It has been decremented. Sorry. Top is actually pointing to this particular location here. Top. And what did I tell you? Once this value is getting, you are getting an output from that. That I have to push it onto the stack. So what is the code for that? See here. Once the switch case is completed, you can see switch starts here, ends here. Once the switch case is completed, push st comma value. What is the value I got here? 12.6 zeros. That I am pushing into the stack. Means where is the stack here? here. So here I'm going to push that particular value. So when I'm pushing that value, what is the output 12? So that I'm going to push it here, and the top will be representing at this particular location. This is the way how exactly this particular program works, and this it will be performing everything with respect to that. Okay, so this is how. And you know, popping is, I think you people know how to pop it up. So your code is completed here. So pop equal float equal to value equal to -1. If top equal to -1, printf stack underflow, else value equal to st of top minus minus. So whenever you want to pop out, you'll be popping out that element first, and then you'll be inserting into value. Then you'll be decrementing top. It will be coming to the next value, topmost element which is present in the stack. Finally return the value which you have removed it. So this is the way how this particular program exactly works. Okay, very easy it is, very simple also. You people can say this. Okay. Uh, let me execute and show you. Let me execute this and show you this. Suppose, let us suppose I'm giving a postfix expression something like 3 4 star 8 plus 4 division. Okay, so what is the expression? Okay, let me take this here. So what is the expression I gave you here? 3 4 star 8 plus 4 slash. So here it will be scanning from left to right. So 3 4 star. So whenever operator comes, perform operation on those two operands. So 3 4s are how much? 12. Okay, completed. So 12 8 plus 4 slash. So 12 8 plus is there. Plus means what you have to do? You'll be performing. So you'll be performing that plus operation between these two. So 12 plus 8, how much you're going to get? 20. 24 slash. Isn't it? Now slash is the division. So we need to perform on these two operands. So 20 by 4 is how much? You're going to get the output as 5.00. So let's see whether you're getting the same output or not. So first time when you perform at this operation, you can clearly see I have shown, I given the printing statement so that you can get an idea. So first we did 3 star 4. What is the output you got here? 12. So that 12 I'm representing here. And after that, what is the next we did 12 plus 8 is how much? 20. You can see here 20 you people have got it. Now what I we did division. So 24 division. So 20 by 4. What is the final output I should get here is 5. So what is the expression I got here is 5. Did you see this? It's a value of the postfix expression. So means whatever the postfix expression you are given here, this one, it has evaluated perfectly. This is manually I did it, and the output I got here is 5.00. Same way when you got executed this program, you got the same output here. Means your program or the logic, whatever you written is correct. This is the way how we can evaluate a postfix expression. Only thing is you people have to give a postfix expression. Remember that. You have to give a postfix expression like this, whatever you're saying here, 3 4 star 8 plus 4, and then finally you'll be getting an expression output value whatever you got. That value will be displaying here in this particular scenario. Okay, so this is the way how this particular postfix expression is done. So I will be giving you the programs, don't worry, this program I'll give you so that you people can understand, and you please try to understand this program and the logic behind that. It's very simple and easy. Only thing you people have to keep in mind is pushing it up and popping it up. So these are the two things which you people have to keep in mind. Remaining everything is process is same. Only should pop up, perform the operations, case operations, and then so it's very simple. And okay. So this is what we have for today's session. So with this we actually completed the first half of the third unit, but there are something extra which I wanted to discuss here, something called as infix notation. So in the next session, if possible, we will try to cover the infix notation and how the evaluation of infix notation is done. Okay, and then we will go for the cues. So this is all for today's session. Thank you for watching.